it is a more complicated math problem, but in terms of the setup, it's not too bad. So let's start here. Let's see, let's clear that off. Go for a dazzling color. So when we think about the forces acting on the ball, while the ball is falling, what are all the forces acting on it?
Gravitational force.
All right. Once it hits the spring, what are the forces acting on it?
Gravitational force and the normal force.
And in this case, the normal force is coming from the spring, so I'm going to call it an elastic force. So I have weight acting down for the first part, and for the second part, I have an elastic force acting up and weight acting down. Are all these forces conservative, or any of them non-conservative?
The second one is non-conservative.
The elastic?
Yes.
If you go to the list, if you wrote it down, the list I wrote over there, elastic force was the second conservative force. It is in fact conservative.
Okay.
So I have only conservative forces here, therefore, if I start with the non-conservative work is equal to the change in energy, 0 is equal to the initial final energy minus the initial energy, or the initial energy equals final energy. At some point, I'm just going to skip straight to here. I have two types of energy, potential and kinetic. What's the formula for potential energy?
For what?
The one associated with weight.
MGH.
The one associated with elastic force.
And the 1/2 K delta X squared.
So it's supposed to be a lowercase k. The initial. What's the formula for kinetic energy?
1/2 mv squared.
It sounded like a single voice. That's how in sync you all were. That's exciting. And then the same stuff except final. MGH final plus 1/2 K delta X final squared plus 1/2 MV final squared. All right. So what can we get rid of? Dropping a ball into the spring. Let's go step by step. Is the mass 0? Is the acceleration due to gravity 0?
No.
If the acceleration due to gravity is 0, what would happen when you drop it? Yeah, it would just hover. Is the initial height 0? Okay. Is the spring constant 0?
No.
Is the initial displacement of the spring 0?
Yes.
Because nothing's hit it yet. The spring is sitting there fat, numb, and happy because delta X initial equals 0. All right. Is the initial speed 0?
Yes.
Because my initial speed, not velocity, is 0 because it is dropped. All right. Final height. Is final height 0?
Yes.
Okay. Why?
Because
not for that reason. You underestimate your powers.
Didn't you say like it could be whatever we want it to be?
Yeah.
So you could say like the top of the spring is 0.
You could.
Okay, yeah.
So you wanna tell Ben you didn't like his idea?
No, it's a great idea. But if you have the top of the spring as 0, does that mean the thing that you're gonna find, how much it's gonna compress, it's gonna be negative?
The height will be negative, yes. And it's fine, whichever way you wanna go, it does not matter mathematically. Just because Ben said 0 first, that's what I'm gonna go with this time. But, so it's 0 because Ben said so. You know, it's conservation of complexity. If we make this 0, we get rid of a term, but it's gonna make this equation, it will, yeah, make that more complicated. All right, I don't know if that's what we're actually trying to find. And what's the final speed?
Would be 0.
It would be. Because we're trying to figure out how much the spring's gonna compress. When it's finished compressing, it has to stop. Maximum compression. XCOM. So we're now left with mg H initial equals 1/2 K delta X final squared. And again, that's what we're trying to find. Now, I know it's going to hit the spring after going 1.7 meters here, and then it's going to compress some more. I don't know how much it's going to compress, but I'm just going to, instead of writing delta all the time, I'm just going to say it's going to compress at some value y. My initial height, since this is where we're establishing 0, our initial height is going to be y plus 1.7. So mg y plus 1.7. And that's going to be equal to 1/2 k. Well, y is also how much it compresses, so ky squared. Distributing, I got mgy plus 1.7 mg equals 1/2 ky squared. I'm trying to find y. What kind of problem am I working on? Am I dealing with here? It's a math problem at this point. Because I know m and g and k.
It's the polynomial.
It is, more specifically. What order polynomial? Now let's stick in numbers, perhaps that one. So that would be 50 y plus 8.5, oh, no, sorry. Plus 85 is equal to 20y squared. That's the math problem. How do you solve it?
Right.
So let's get it all terms, get a set equal to 0. Let's see, we can get rid of half this. So 20y squared minus 50y minus 85 equals 0. And if you want, that's one where you want to put the math in. So we just go straight from that. That's y is equal to 50 plus or minus the square root of 2500 minus 4 times 20 times negative 85 divided by 2 times 20.
.66 or negative 1.16.
So what was that?
1.16.
1.16. Okay. What do these answers mean? I got two answers. They both have physical meaning.
Would one be its minimum compression and one be its, how much it springs back?
Yeah. So it's going to compress down 3.66 meters, and then if the balls or whatever the object stuck to the spring, when it bounces back, it's going to go 1.16 meters above where the spring initially was. So anyway, that introduces several things, and then we can make it even more interesting by putting it on an angle, on a ramp. Maybe there's friction into it, so the energy is not conserved. Lots of fun. But notice we aren't using F equals to MA. It's built into it. The F equals MA is hopefully somewhat demonstrated. Well, I sort of skipped over that part. Then we'll, in the derivation of the kinetic energy formula, we use F equals MA. Anyway, Newton's laws they're in there. Any questions before I hand back tests and neat junk like that?